Hi doctor, we are from Group 20. So this gate level full adder design is a fundamental combination circuit that adds two operand bits A and B and a carry in to produce a sum and a carry out. The design uses XOR gate for sum computation where the first XOR combine A and B and the second XOR process the result with C in to generate the final sum. AND gates calculate partial carry terms, one for A and B and another for A XOR B and C in, which are then combined using an OR gate to produce the carry out. Next, this 4-bit full adder and subtractor design perform addition or subtraction of two 4-bit numbers, which is A 3 to 0 and B 3 to 0, based on a control signal. XOR gate invert B for subtraction and 4-connector full adder handles the operation with carry or borrow cascading through each stage. Output include a 4-bit result, which is S3 to 0 and a final carry or borrow.
Okay, next. This is basic multiplexer. The design and functionality of a 4-to-1 multiplexer using basic logic gates such as AND gates, OR gates, and NOR gates. The circuit takes 4 data inputs, which is I0, I1, I2, I3, and 2 select lines S1 and S0 as control inputs to determine the outputs Y. The select line combined with the logic gates ensure that only one input is active at a time, while the OR gates consolidates the result to produce the final output. Okay, next. This circuit is a 4-to-1 multiplexer system that routes one of 4-bit inputs passes to a 4-bit outputs, controlled by two selection lines, which is S0 and S1. Each bit is handled by a separate multiplexer, making it suitable for data routing selection.
This is a 4-bit register implemented using 4D flip-flop. Each flip-flop has a dedicated data input D0 to D3 and share a common clock and along with a clear signal. On the rising edge of clock, the data present at each D input is latched into the corresponding flip-flop and reflected at the output Q0 to Q3. This is a final digital circuit of ANU component that combining multiplexers, an adder subtractor, and a flip-flop. Two 4-to-1 multiplexers are used to select input I0 to I3 for two 4-bit buses A3 to 0 and B3 to 0 based on selection signal S1 to 0. The outputs of the multiplexer Y3 to 0 serve as input to a 4-bit binary adder. The adder processes the selected input to produce a 4-bit sum S3 to 0 and carry out C4 with an initial carry in C0. The sum output is fed into a D flip-flop which stores the result on the rising edge of the clock and input it as Q3 to 0. A reset signal clears the flip-flop when activated. Thus, this circuit can perform conditional addition operations and store the results, making it suitable for arithmetic logic unit ALU or data processing applications. This waveform simulation generated by a digital logic design tool showcasing the behavior of a 4-bit adder circuit with multiplexers and flip-flops. The simulation includes signals for two sets of inputs A0, I0 to A3, I3 and B0, I0 to B3, I3, selection signals A selector and B selector, carry input C0, clock, reset, sum output Q and carry out C4. The waveforms show how the input values A and B are dynamically selected based on the multiplexer select lines A selector and B selector, processed by the 4-bit adder and stored in the flip-flop on the rising clock edge. The resulting sum Q and carry out C4 values change accordingly with time, demonstrating the circuit's correct functional behavior over various input combinations. This simulation validates the timing and logical operation of the design circuit, ensuring its functionality for arithmetic operations. After simulation, this is a result of the waveform of the digital circuit of arithmetic logic unit ALU. Thanks for listening.